Hey there class, Mr. Posky here. Hope you're having a good day so far. So this video is just on the 3.5 homework. We're going to take an extra day on it because it is very challenging, especially because we quizzed and now today we're not able to meet. So I wanted to record this video to go through every single problem on this homework to make sure you guys feel comfortable with it, because it is a very challenging assignment, and that way I don't want to push ahead if you guys are uncomfortable with that. I've been getting a lot of feedback that it's been a really challenging assignment. So if you've been, worried, don't worry. I'll take care of you here, okay? All right, so solve each word problem. Remember to define your variable and write an equation. All right, so number one says 17 more than a number is 42. 17 more than a number is 42. Find the number. Okay. Well, if you recall, a number we're just going to call x, right? A number is like, we don't know what the number is, we're going to call that x. And if you remember before, 17 more than and less than needs to go at the end. So over here, we're going to put plus 17. Okay? So I'm just kind of breaking it down above the problem to kind of help me figure this one out here. Is 42, means equals. And 42 is the number it's equal to. So that's going to be our equation. X plus 17 is 42. Now, how do we solve for x? This is a pretty easy one to solve for x. We're going to subtract 17, and x is going to be equal to 25. All right. Question 2. The sum of three consecutive odd numbers is 291. Find the three numbers. All right, this one's a little challenging, okay? And this is kind of a hard concept here. We don't know what the three numbers are. We're trying to use algebra to figure them out, okay? It could be 13, 15, 17. It could be 51, 53, 55. We have no idea. And to take the time to guess when they all add up to 291 would be a really big pain in the butt. So what we're going to do is we are going to pick three random consecutive odd numbers. So I'm just going to go 17, 19, and 21. All right, we're not sure what the pattern is. I would do this every time just to figure out, make sure you do the right pattern, okay? So I'm going to call the smallest number x, and then I'm going to compare the other two numbers compared to x. So each of these numbers is going to have x in it, but we're going to have to compare like what those numbers are in relation to x. So if x is 17, how do we get from 17 to 19? Well, we add 2, right? So it's going to be x plus 2. And how do we get from 17 to 21? Well, that's going to be plus 4, so it's going to be x plus 4. Okay, so these are not the numbers. I'm pretty much guaranteeing, I know the numbers, I have them here, but these are not the numbers, okay? These are just to help us figure out the pattern, but this pattern will work for any consecutive odd numbers the sum of them will all, use that pattern, okay? No matter what consecutive odd numbers you pick, they will all follow the pattern of the smallest number plus 2, smallest number plus 4. So now what we're going to do, sum means we're going to add. So we're going to add all three of these numbers. We're going to add x plus 2 plus x plus 4 is 291 is equals 291. Okay? Now we're going to solve this just like we normally would. So are there anything to distribute here? No. Any like terms? Yeah, we got two groups of like terms. We got 3 x's here. Then we got 2 and 4. So what's x plus x going to be? That's going to be 3x. And then 2 plus 4 is 6 equals 291. That's really bad 9, but okay. Any other like terms? No. Now we need to get this 3x by itself. So how do we do that? We need to subtract 6. So now we have 3x equals 291 minus 6 is 285. And what's the last step? We're multiplying by 3, so the opposite of multiplying by 3 is to divide by 3 to undo what's happening to the x. And x is going to be equal to 95. Is that our final answer? One thing with these problems, you want to make sure you find what they're asking for. It says find the three numbers. What number do we find? Do we find the smallest number, the middle number, the biggest number? Well, if x is 95, we found the smallest number. So how do we find the other two numbers? Well, we're just going to count up by 2. We can actually plug it in here if you wanted to, but we can just count up by 2 and 4. So we're going to have 95. Count up by 2 is 97. And count up by 2 more is 99. And those three numbers, which is pretty crazy to be able to solve using math. I mean, you guys may not be impressed, but it is kind of cool that we can like figure out any three random numbers like that and figure out what they're going to add up to that, and we're going to find the three numbers that work. Okay, moving on. 14 less than 6 times the number is 70. Find the number. All right, so again, if you recall, 14 less, no, let's start with a number here. Here's a number. We have 6 times the number, and we have 14 less than that. So 14 less than is going to go at the end. And less than is what operation? It's going to be minus 14, then is 70. Okay, so you want to just kind of play around with it a little bit and kind of figure out what it's saying. Start with a variable, a number, and then figure out what's happening to the variable. So it's 6 times the number, and then it's 14 less than that. So it's going to be 6x, I'm going to write that smaller actually, and over here. 6x minus 14 is 70. 6 times a number, and then less 14 or minus 14. All right, now we got to solve this. Anything to distribute here? No. Any like terms? No. What's the next step? Well, we got to get that 6x by itself, so we're going to do the opposite of subtracting 14, which is adding 14. We're doing inverse operations. Oops. So we get 6x equals 70 plus 14 is 84. Last step to solve for x is to divide by 6. And we're going to get x is equal to 84 divided by 6 is 14. So that's the number. If you were to plug in the number 6 times 14 plus minus 14, that's going to work. That's going to be the number that works. Okay, moving along. The product of 3 and 7 more than twice a number is 39. Find the number. This one's really tricky, okay? All right, product of means multiply the first thing times the second thing, okay? So it says the product of 3 and something. We're going to do 3, and then we're going to do times, okay? It's like it's whenever they do these word problems, they say the product of this and this. Usually they're going to do like parentheses, and they're going to put whatever the rest of it is in the parentheses here, okay? 7 more than twice a number. Okay, well, twice a number is double, right? So 2x, and then 7 more than needs to go at the end, right? So it's going to be plus 7. And we have the is 39. We're going to close parentheses. We're going to close parentheses after that. Okay, so more than goes at the end. The product of 3 and all of this is 39. So the product means multiply, so we're doing 3 times that entire thing in the parentheses. And it's just decoding, really. It's kind of like figuring out a puzzle here. But this is a pretty challenging one. This is a pretty tricky one. So just pay close attention, and you know, you guys are doing great. This is hard stuff. So we have 3 times, I'm actually going to move it over. We have 3 times the quantity of 2x plus 7 equals 39. Now we got to solve this. Anything to distribute here? Yes, we do. We got to do 3 times 2x and 3 times 7. 3 times 2x is 6x. 3 times 7 is 21 equals 39. All right. Anything else to distribute? No. Any like terms? Also no. Now we got to get the 6x by itself. How do we do that? We're going to subtract 21. So we're going to have 6x equals 39 minus 21 is 18. Last step to solve this is to divide by 6. X equals 3. All right, almost done with the front page. You guys are doing great. The sum of 3 consecutive numbers is 336. Find the 3 numbers. All right. So consecutive numbers just means any numbers in a row. So I'm going to pick 3 numbers in a row. How about 11, 12, and 13? You guys can pick any numbers you want so that are in a row. It doesn't matter. Remember, we call the smallest number what? Call the smallest number x, and then we need to compare. These are all going to be in comparison to x. I could call this x, y, and z, right? I could call it x, y, and z, but if you do x plus y plus z equals, what, 336, how do you solve that? See, that one of the things with algebra is you can't really solve equations with multiple variables like that. You need one variable. So by comparing them all using x, we kind of make it easier to solve, all right? Because even if you solve for x here, you subtract y, subtract z, you're going to get x equals 336 minus y minus z. Well, what does that even mean? That's not a number. That's just like nonsense. You know what I mean? Okay? That's kind of why we're doing this. We could call them x, y, and z, but it's better to just call them all some form of x. All right, so how do we get from 11 to 12? It's going to be x plus what? X plus 1. And how do we get from 11 to 13? X plus 2. So this is the only pattern that's different than the other two, even though it's like this. It's kind of weird that like, you know, it was x plus 2, x plus 4. That works. This works for consecutive even and consecutive odd numbers both, just because they're like shifted one over basically. But the one that's different is consecutive numbers because they're only adding 1 and adding 2. So the sum again means we're going to add these up. So we're going to do x plus 1 plus x plus 2 equals 336. All right, anything to distribute here? We're solving. No. Any like terms? Yes, we got x, and we have 1 and 2. What is x plus x going to be? That is 3x. What's 1 plus 2? That is 3. Equals 336. Now we got to solve this. How do we do that? Anything? Oh, wait. We got any other like terms? Okay, now we need to get the 3x by itself. So we need to subtract 3. 3x equals 336 minus 3 is 333. Last step to solve for x is to divide by 3. So x is going to be equal to, that's going to be 111. So 111 is the smallest number, so we're going to count up by 1. 111, the next consecutive number is 112 and 113. So those are the three numbers. Now be honest, if you were given like 3 numbers in a row that add up to 336, would you want to like guess what numbers those are? You know how like much a pain in the butt that would be? Like, give me a break. No way. You know, so this is kind of a cool way to be able to find certain things. Yeah, I would not want to spend time guessing that these are the 3 numbers that work. That would be a pain in the butt. All right, cool. One last example on this page, and we'll do the next page together. So the product of 5 and 4 more than a number is 50. Find the number. So again, we're doing 5, the product of 5, and then we have a number which is x, and then 4 more than it's going to go at the end, right? Close parentheses equals 50. The product of this and multiply that times whatever the rest of it is in parentheses. We have 5 times x plus 4 equals 50. Okay? And you'll get better at this the more practice you get. It's just kind of just takes some time and some energy, and it's hard stuff. This is very challenging. All right. We have 5 times x plus 4 equals 50. So anything to distribute here? Yep, we got the 5 to distribute. So 5 times x is 5x. 5 times 4 is 20. And we get equals 50. Next step is to get 5x by itself by subtracting 20. Now we have 5x equals 50 minus 20 is 30. Divide by 5. X is going to be equal to 6. All right. Cool. Now for the hard ones on the back. Oh boy. All right. So let's get into this. Okay, the perimeter of a triangle is 31 feet. The second side is 4 times as long as the first side, and the third side is 2 less than 6 times as long as the first side. Find the length of each side. Oh my goodness, this is so much. So much to look at. Let's break it down a little bit here, okay? I'm going to call each side A, B, and C. Okay? So I'm just going to call the first A, I'm going to call that X. Okay, I like to use X for stuff. Because basically what they're saying is they're using the first side to compare the second side and the third side, right? So we're going to call whatever they're using to compare the other sides, call that X. That's going to make it the easiest to work with here, okay? So the second side, which is B, let me move B down a little bit, actually. A, B, and C. Oops. So we have B. It says the second side, this is B, is 4 times as long as the first side. Well, if the first side is X, what's 4 times as much as X going to be? That's going to be 4X, right? Good. And then it says the third side, which is C, is 2 less than 6 times as long as the first side. So less than needs to go at the end, so 6 times as long is going to be 6x. And then less 2 is going to be minus 2. All right. So, yeah, the third side is 2 less than 6 times as long as the first side. These are all in comparison to x, because x is kind of our baseline here. Whenever these kind of problems, whenever they give you, like, you know, this is compared to this and this is compared to that, whatever they're comparing it to, make that x, and it makes their life a lot easier. Okay, in perimeter, the perimeter is 31, right? Perimeter is the inside or the outside of a triangle. It's the outside, so we're literally going to add up a plus b plus c. I'm going to zoom in a little bit here. A plus b plus c equals p. But a was x, b was 4x, and c was 6x minus 2. And then the perimeter was 31. Okay, so once you find that hard stuff of labeling, the easy part is just kind of solving from here, okay? All right, so now we need to solve. Anything to distribute here? No. Any like terms? Yes, we got x, 4x, and 6x. So we got x plus 4x is 5x, 5x plus 6x is 11x, minus 2 equals 31. Any other, so I should ask if there's anything to distribute. There's nothing to distribute. There were like terms. Anything else, any other like terms, or no? Okay, now we need to move stuff around. We need to get that 11x by itself, so we're going to add 2. Get 11x equals 33. Solve for x by dividing by 11. It's the opposite of multiplying by 11. X equals 3. Okay, so we know x equals 3. So I'm going to go over here now. A equals x. Well, let's see here. How do I want to write this? X equals 3, so A equals 3. That's one of our answers. Now we need to find B. B equals 4x, right? B equals 4x, and this is also supposed to be, I think it was feet. Yeah, sorry, I gotta use my labels. Not good for a teacher to not use his labels, Mr. P. Okay, so B is 4x. If x equals 3, we're gonna do 4 times 3, which equals, B is going to equal 12 feet. All right, so this is A. Then we had C, which was 6x minus 2. So we have 6x minus 2, which equals 6 times 3 minus 2, right? We're just plugging stuff in. Because x equals 3, so we're just plugging in to solve now. So it's going to be 18 minus 2. So we're going to have C is going to be equal to 18 minus 2 is 16 feet. All right. And there's your answer, okay? So on your quiz, you probably won't see one like this. What you are probably going to see is number 9, something similar to number 9, okay? I'm just kind of giving you a heads up here. This is a pretty challenging one. It is legit and important, but just, just follow along, do your best. This is hard stuff. Like I said, I keep saying it's hard stuff because it is, but let's keep moving along here, okay? Number 8, when carpeting a room, floor design specialist cuts a 32-foot long piece of carpet into 2 pieces so that one piece is 8 more than 2 times as long as the shorter. How long is each piece of carpet? All right, so I'm just going to go like this. I'm going to go like this. Okay, I'm going to call, let's see here. We'll do shorter and longer, right? So I'm going to call the shorter one. So it says the long piece is 8 more than 2 times as long as the shorter. So we're going to call the shorter. We're using the shorter one to compare the long one, so we're going to call that one X. Okay? Next piece, it says 8 more than 2 times as long as the shorter. So remember, we do 8 more is going to be at the end, and then 2 times the shorter is going to be 2X. And there we go. We got 8 more than 2 times as long as the shorter one. If the shorter one's X, it's going to be 2X plus 8. All right, it says how long is each piece of carpet? Well, the entire length is 32 feet, so we're going to add them up equal to 32 feet. So X plus 2X plus 8 equals 32. All right, I'm skipping ahead here. Anything to distribute here? No. Any like terms? We're just solving now. No, like terms. We have X and 2X. What's X plus 2X going to be? 3X plus 8 equals 32. Any other like terms? No. Now we need to get the 3X by itself. We need to subtract 8. So we get 3X equals, that's going to be what, 24? So x is going to be equal, oops, I skipped a step. We need to divide by 3. X is going to be equal to 8. So the shorter one equals 8 feet, because that was x. Then we had the longer one equals 2x plus 8. Let me move that up a little bit, actually. The longer one equals 2x plus 8, but if x equals 8, we're going to do 2 times, we're plugging this in for here, 2 times 8 plus 8, which equals 16 plus 8, which is going to equal, what, 24? So we get, the longer one's going to be 24 feet. Okay, so after you figure out what x is going to be, then you just got to plug into the other things to find what they're equal to. You plug in for x and you simplify using PEMDAS, then you get your answer. All right, 2 more examples. Pay close attention for number 9 here. Okay, this is an important one. So the perimeter of a rectangle is 44. The length of the rectangle is 8 more than the width. What is the width of the rectangle? All right. A hint for these kind of problems, usually they compare the length to the width. All right. They compare the length to the width. They don't usually compare the width to the length. So we're going to call the width just W. All right. It says the length of the rectangle is 8 more than the width. The length of the rectangle is 8 more than the width. So the length is equal to 8 more than the width. It's going to be W plus 8. Right? 8 more than the width. So it's the width plus 8. Cool. We also know the perimeter equals 44. Okay, just a reminder, I went through this in the video, but what is perimeter is the inside or the outside again? I forget. It's the outside. So let's add up the outside. So we have a length, a width, a length, and a width, right? If we go around the outside, length plus width plus length plus width equals P, right? But if we combine like terms, this is where the actual formula comes from. We got L and L, we got W and W. So we have 2 L's plus 2 W's is going to equal P. And this is the formula that you'll see mostly for perimeter of a rectangle. Okay, now, but you could still just add them up if you wanted to and do it this way. That's totally fine. But like I said, we can't solve this because we have L and W in here. We need one variable. So that's why we compared the length to the width. So we're going to use the width. We're going to plug in right here for L. So we're going to have, zoom in really good, 2 times W plus 8 plus 2W, right, the rest of the equation the same, equals P, and the perimeter, if you remember, was 44. Okay, now we just got to solve from here. Anything to distribute here? Yeah, we got to distribute the 2. What's 2 times W going to be? 2W. What's 2 times 8? 16. Anything else to distribute here? No? Any like terms? Yes, we have like terms. We have 2W and 2W. So that's going to be 4W plus 16 equals 44. And then now we need to solve this. So we need to get the 4W by itself. So we're going to subtract 16. We're going to have 4W is going to be equal to, what? 28. When you subtract 44 minus 16. Divide by 4 to get W by itself. We're going to get W is equal to 7. 28 divided by 4. And actually, what is it asking for? It's asking for just the width. So we found the answer. It's 7. But let's find the length too. So the length equals a W plus, what, 8? So we can literally just solve for the length too. Why not? So the width is 7. 7 plus 8. So the length is going to be equal to 15. All right, sounds good. So I might say that you guys can stop the video here if you would like, but just listen for a second. The last problem is almost an Algebra 2 problem. It is very challenging, but if you'd like to watch and see how it is, if it's bothering you that you didn't know how to do it, I would encourage you to watch it, but otherwise don't worry about this hard of a problem going forward to be tested on, okay? But stick around if you want to see how number 10 works. All right, number 10, your little sister's piggy bank contains $13.10. There are 4 less dimes than nickels, and there are 3 times as many quarters as nickels, how many of each of the 3 coins was in the bank? All right, this one's challenging because we have to take into consideration how many like dimes, nickels, and quarters there are, as well as the like value of the dimes, nickels, and quarters. Okay, so this one's challenging. So, basically, what we're going to do is we're going to multiply the value of the coin times the number of coins, basically. Okay, so if I call n is nickels, right? How much does a nickel cost? It's 5 cents, right? So I'm going to put I'm going to put 0.05 times n. The number of nickels times the amount that nickels cost is going to equal the total value of the nickels that are present, right? Okay, how much does a dime cost? That's 10 cents, right? So 10 cents times dimes. This will give us our total value, right? Right? The amount that it costs times the number of things you have gives you a total cost, okay? All right, then we also have quarters, which is 25 cents, right? Times quarters. And this all adds up to $13.10. Okay, now here's the tricky part. And this is kind of a hard problem, like I said. So, they're comparing dimes to nickels and quarters to nickels. What do you think we're going to use as our variable here? We're going to keep nickels the same. So I'm going to call nickels, it's just going to stay nickels. I'm just going to use n for this one. Now, we need to, so because they're comparing, whatever they're comparing to, you're going to call that, just keep that the variable you're going to use. Now, dimes, what does dimes equal? It says there are 4 less dimes than nickels. So the dimes is going to be equal to nickels minus 4. Nickels minus 4 is going to be dimes. All right? And it says we have 3 times as many quarters as nickels. Okay. Well, 3 times as many quarters as nickels is going to be 3n. All right? So now we have, kind of like we were doing before, we have all one variable. We have all this money is being compared to nickels. Okay? We have what it's called is we have dimes in terms of nickels and we have quarters in terms of nickels. Okay, so we're going to plug into that formula now. We're going to plug those in. So we got 0.05n plus 0.10 times dimes, which is n minus 4, plus 0.25 times quarters, which was 3n. And that equals 1310. All right, now we got to do some hardcore solving here. All right, this is tricky. Do we have anything to distribute here, first of all? Our first step. Yeah, we got to do 0.10 times n and 0.10 times negative 4. 0.05n plus 0.10n. And then we got 0.1 times negative 4 is negative 0.4. Plus, then we got 0.25 times 3n is 0.75n equals 1310. Another reason this is challenging is because we haven't done any solving with decimals yet. We're going to learn that tomorrow in 3.6. This is why it's an extra hard problem. So, all right, let's keep going here. So, anything else to distribute? No. Any like terms? Yep, we got 0.5n, 0.10n, and 0.75n. And then we got this is by itself. So, that's going to be 0.9n when you combine those. Minus 0.4 equals 1310. Now, same reason, if we had 9n, this is where this kind of applies to solving. If we just had 9n minus 4 equals 13, even though these are weird numbers, what would we do first? We would add 4 first, right? Well, it's the same thing here. Even though we have weird numbers, it's still being multiplied by 0.9 and subtracting 0.4. So we're going to do the first thing, we're going to get that 0.9. We're going to get that 0.9n by itself, so we're going to add 0.4 to both sides. So we're going to have, we'll write it over here, 0.9n equals, when we add 1310 plus 0.4, we're going to get 13.5. Now again, if we had 9n equals, I don't know, 36, what would you do next? You would divide by 9, right? So we're going to do the same thing here. We're going to divide by 0.9. Even though it's a decimal, we can still divide by whatever's being multiplied here. And n is going to be equal to, when we divide that, 15. So we have 15 nickels. All right. Then we have dimes was n minus 4, which equals 15 minus 4, right? So So dimes equals 11 dimes. And then we had quarters was, what was it, it was 3 times nickels, and nickels was 15, so 3 times 15. So quarters equals 45 quarters. So that one was really challenging. If you stuck around to watch the end of the video, give yourself a pat in the back. That's pretty awesome. This is especially hard because we haven't done solving with decimals yet, which we'll learn tomorrow. So thanks for watching. Sorry for giving you such a hard assignment and giving you a panic attack, but I hope I took care of you here and you guys feel better about this stuff. Thanks for watching. Have a great day, and we will see you soon.